Swayam Prabha. Digital India. Educated India.
Hi everyone, welcome back again to the NPTEL online certification course on research methodology for planning and architectural studies. In our last lecture, if you recall, that we discussed about interpreting data. There I mentioned about something about mean, median while describing the box plot. So some of you probably got it very right, and maybe some of you are having certain doubt about those terminology, who are just doing it for the first time, understanding this kind of concepts. So for that, definitely we will be discussing it in detail in this current lecture. So the current lecture is titled as Descriptive Statistics, lecture number 33. So what we are going to learn out of this particular lecture, they are as follows. We will discuss about the role of descriptive analysis in research and how researcher can get some first hand insight about the information or the data collected through survey, through interview, or through some kind of experimental setup. In that case, there are certain typology, or you can say certain typologies where we are going to measure the frequency of certain variables, like it may be just mostly you can say that frequency of certain score, okay, exam marks, or maybe the age group, or like you can say the frequency of male female in a particular sample, or else like it can be something where we also need to understand the measures of central tendency. So out of all informations, what kind of central tendency means what kind of average value that we are looking for, or whatever the average value for the entire data set, that we can get it from this kind of measures of central tendency. So normally measure of frequency is very much useful for some sort of, you can say, the ordinal data that we discussed earlier in detail, or maybe it is good for nominal data. Okay. Then also we will discuss about the variability in data. So either like in the box plot we have seen that how it is variable, like from different kind of percentile, like for 25th, 50th, which is considered as a median for the box plot. So those kind of measurements are also there as descriptive statistics. So basically it comes from description of the data, and there are different means of doing it, and definitely it is going to help you to give some sort of first hand insight about the entire data set before you really go for further analysis and do some sort of advanced computational thing, or maybe statistical method that you will apply to bring certain useful information. And then finally we will summarize our learning at the end of this presentation. Now what is descriptive analysis? So descriptive analysis basically summarizes collected information or data to understand the patterns and trends. Now if your collected information is showing that based on your data, simple data collection in a particular city or in a particular village, that maximum say maybe 48% out of 50 they are youth population, they are ranging in a youth group. So maybe considering say you can say 20 to 40, that particular age, that where you are going to get the highest number among like other age group like above 60 or below 20. So this is some sort of, you can say that kind of frequency, or else it can be a pattern that okay, when you study two variables together. In the previous example, like in the previous lecture, we have taken one that it's all about you can say about the number of hours of study and then the score. So those kind of relationship, or maybe you can take other, like it maybe you can say that population density and then the water consumption, or in such cases, like depending on your research, depending on the variables that you have measured, you can take up certain kind of representation and you can identify those kind of descriptive statistics means or measures to get certain first hand idea. It is very much critical in making informed decision based on available information, right. So in a particular sample, if you simply get that okay, so there are certain sort of distribution where you can say that maybe you can say 30% to 20%, this is 30% and then 40%. These are the different distribution of the age group, okay, and then area of interest, that this particular 30%, again you can go for further dividing into among 30%, there is a split of say 50%, 50% of male and female. So maybe if it is something the age group below 20 years, and then you can do further analysis, or you can bring such kind of pie chart to represent their distribution as well. So this is one way you can do it, or else you just simply make a plot and where you can say that okay, this is something where this is 30%, this is 30% and then this is 40%. Okay. The data representation may be different, that we will discuss in our next lecture, that what type of data charts and other combination you can use for a better clarity of your descriptive statistics or any statistical inferences that you can make through those graphs tables. But for this time being, so we can take help of different graphs to represent this kind of descriptive statistics. So normally whenever you collect any information through experiment, there also you have to give those kind of data distribution, and if you have collected information from a field survey, respondent survey, so you have to give a respondent profile. So normally male, female, or maybe you can say other gender, age group, car ownership, okay, income level, etc., etc. So that normally we used to give a table, or maybe we can represent with a pie chart or a graph, whatever can fit better for your understanding and for readability of the research article that you are writing. But they are going to give some basic insight about the overall data set, that whether the data is too much like bias, or maybe that particular information is not representing the population. Say in case that in a particular sample you will find that maybe it is the case that where you get 70% male and 30% female, but in actual the population is something different. So in such cases, like you can always take a look, and while the survey is on, you can also have the look simultaneously, so that you can change your sampling strategy. If you find that okay, in my case is a stratified sampling, and where I want to represent male female almost equal, so maybe you can stop doing survey for the male respondent and you increase the number for the female. That way also you can do. So this kind of bar chart, simple descriptive statistics can also help you in taking some decision in your survey process and the post analysis of collected information. Coming to the importance in architecture and planning, so definitely say for example, if you want to understand the historical trends, so understand architectural trend and urban development patterns. So say in this particular case, like if this is some kind of region where you want to study, and probably if you have a temporal data set, so probably you will find that maybe the initial settlement was something like this, and then gradually it expanded over time, right, and then it expanded on that side even further. So, in such cases you can always have those kind of descriptive statistics like the percentage of build form and the settlement, where probably in that particular boundary it was as low as say 10%, now maybe in this case it is going for the 20%, maybe it is 40%. So, there is a change and increase over time. You can relate them that in 10 years, 20 years, or then you can say that probably this is something in 10 years the growth was only 10%, but next 10 years it is almost the gap is multiplying. So, this is something you can make. It will also help for this informed decision making. It aids in material selection, environmental impact assessment, and resource allocation for any such kind of infrastructure projects or any building. So, this is something where you can see the distribution of materials or the cost, etc. Design efficiency, definitely through this you can also optimize the space planning and usage based on past uses of the data and trends. So, if you have those kind of information, you can understand that okay, for such kind of location where you have designers sitting like this and then another options that somewhere you have a sitting like this. So, in both the cases like how people are like interacting with those spaces, you can take a call, and then through that the percentage and all those simple values can take or give you some sort of direction like what to take uh, ahead, and what kind of changes that you require for your space planning. Now, coming to descriptive analysis. So, most predominant way of doing this analysis, one is the measure of frequency. So, in this particular case we can use histogram that in the previous lecture we have discussed it, right, where we simple frequency can give you those kind of information. So, where you will see that okay, there is some kind of value where it is having a maximum number of observations they are merging at that particular time. So, this is one, and again we have also discussed about the steam and leaf thing. So, where there we have taken those kind of age group example, and then we can write the variables here. This is one. Next is measures of central tendency. So, when you plot the histogram, next stage is that you can try to identify that what type of distribution they have. So, where exactly it is having those kind of you can say the mean value, or it is something like mean, median and mode. So, it is all about like looking at the data point and where exactly like the average value or something in between value, the middle value that you can do in this particular measure of central tendency. Now, coming to the measures of dispersion and variation. So, here also you can find out certain kind of values where you can see those kind of variation where you have the data. Say for example, this is something where you get exactly it is a normal only distributed data, but it may happen that it is not like that and there is some kind of skewness. So, either it is like skewed on the left hand side or maybe it is something on the other side. So, in all those cases you find that there is some sort of variation that you observe in the data set. So, maybe if it is A, it is B, it is C. So, here you have certain kind of left side skewness or shift, and here you can get something on the right side skewness. So, then in that case there is a shift of those kind of like you can say the mean value and all. So, whenever it is perfectly fit, so your mean, median, mode will be equal. So, we will discuss that. Now, measures of position is also important. In this case what we are going to see, it is about where your data lies, whether it is in that particular at the mid value. So, individual data where it lies. So, it is like 50th percentile, this is 25th and this is 75th, and then probably the other values are on that range, and then you can find out some sort of outliers. Measures of frequency. So, this is something you can say that measures of frequency are statistical measurement that professionals use to summarize the values in a data set and make them easier to understand. Say this is something a simple frequency where it is a count of number of tourists. So, for that definitely here out of all, then it was found that 182 number of tourists, they are male, 235 female, and then also we have 27 in other category. So, where it is just something like you can say a nominal data, right, where this male, female and other thing, they are not having any sort of value difference or something. So, they are just some name. So, they are all categorical data and nominal. Otherwise, you can also have this kind of grouped frequency. So, in such cases maybe you can collect information with the actual age and then you just make them in a group. So, age group 0 to 5, 5 to 18, 18 to 40, 40 to 60 and 60 and above, and out of total sample or the population you calculate the percentage. If you add up all of them, it will give you 100%, but from here it is very obvious that 42% is that age group where 18 to 40, that that I just referred earlier, and also 40 to 60 is considerably similar as like 5 to 18, but where the child population and elderly population, they are compared to the others, they are low as 6 and 8%. So, this is hypothetical, definitely in your case this may change, but normally we can represent in this kind of group frequency. So, I can give you another example of group frequency. Suppose you are doing a particular speed survey, spot speed survey through radar gun. So, you want to measure the instantaneous speed of any vehicle passing a particular point. So, and you observe 100 vehicles and their speed. So, you may have all 100 values, those are discrete values. So, somewhere you may get that it is 70, if I take the round figure 70, 80, okay, in a particular expressway context I am just mentioning. So, you can have any values like that. So, one way it is something like you can just take the average, you can take the summation and then you can take the average, or else in order to show it in a frequency table. So, you can always make a chart that okay, less than 60 kilometer per hour, 60 to 80, 80 to 100 and above 100, and then you make a count and then write the frequency. Suppose you get certain number and then from there you can also calculate the percentage. So, in this case it is percentage, these are not actual value. To get the actual value you just need to know the total population that you have surveyed. You multiply with that, you get the exact number, right. Hope this is clear to you. We will move forward to this particular slide where measures of central tendency. So, there are three main measures of central tendency: mean, median and mode. Okay, we will learn one by one. So, what is mean? This is average of a data set calculated by adding all numbers together. First you have to make a summation and then dividing that particular sum by the number of total count of those numbers. So, say for example, if you have 10 observations, 10 values. So, first you have to add all 10 values. So, that is why it is the summation. You can say this is, if it is 10 for your case, so there should be you can say x1 plus x2 plus x3 like this, and then you finally have x10 value and divided by 10. So, this is simple mean. Now, in this particular case, if it is for any number, so say we can represent this is I 1 to n and this is I, and n is the total number. So, in this case definitely it is something like capital N. So, we have all the numbers. So, start with first value to the last value and we can divide it with the total number. So, this is also referred as a arithmetic mean. Now, there is another alternative to this which is called geometric mean. So, in geometric mean it is something different. So, in geometric mean this should be calculated in a different manner. So, in this case you have to make product of all these values and then you have to divide, you have to go for nth root if there are total n number of observations. So, we have to go for nth root. So, if there are only 2 data points, so in that case it will be simple like square root of the product. If it is like 3, so then cube root. If it is 10, so 10th root of this product. So, in both the cases the values will change little bit, but overall pattern will be same, right, which will be higher, that will be higher, which will be lower, that will be lower in both the cases. Now, take up one example for the mean. Say city planners, they want to know average building height in a particular district to inform zoning laws, aesthetic cohesion and infrastructure need. Hypothetical data in this case, suppose we have a small district with following building heights. Normally they are varying with 15 meter, 12 meter, 18 meter, 20 meter and 14 meter. So, then calculation is the mean height is summation of all of them and then divided by 5 because these are 5 data points. So, 15.8. So, the interpretation that this information can be used that okay 15.8 is the mean height of any building in that particular studied area. So, this will help to guide planning decision, for instance to determine a new proposed building whether it is significantly taller or shorter than the average and how it might fit into the existing skyline. So, this is just one example of calculating mean. Coming to median, in this case the median is the middle number in a sorted list of numbers and then the sorting of the data can be done either by ascending or descending order. So, here we are not calculating or adding up and dividing it. So, we try to find it out. Say for example, if you have simple number like 1, 2, 3, 4, 5, this is already sorted. So, in this case we just take the middle value. So, in this case it is odd number. So, the middle value is 3. So, I can say that from 1 to 5, if these are all discrete value 1, 2, 3, 4, 5. So, 3 is the median, but case will be little different when you have some sort of even number. So, for that what we need to do, as because whenever we say middle, so any odd number the middle value is very easy to find because you have exact number on left hand side and exact number on right hand side. So, this is something you can say n by 2, n by 2, but for even number you have to do this kind of calculation where you have to take the value of n by 2 and then n by 2 plus 1, that particular term, and then this particular two things to be added and divided by 2. So, say for example, in this case if you have 1, 2, 3, 4, 5 and 6, right. So, in this case if you say the half of the number, so here you have this particular thing where it is, you can say that 3 and 4, these are two numbers because this is one particular half and then it is the next plus 1. So, for that particular case the median for this series will be 3 plus 4 by 2. So, this will be 3.5. Now, for the median of odd number it is very simple. So, in this case also you can say that how to calculate it is very easy. So, for that we have 1 to 5. So, 5 plus 1 divided by 2. So, this is 3, right. Now, example, An architect may want to understand the typical number of floors in a residential buildings within a specific area to guide design standard or inform policy decisions for those kind of building code and all. Hypothetical data, maybe the number of floors in a small sample of residential buildings is 5, 3, 6, 12, 4, 7, 5. So, first we have to arrange the data in ascending order. So, 3, 4, 5, 6, 7, 12. So, in this case also you have odd number, right. So, odd number it is very easy to calculate. So, with these 7 buildings in the list, the middle value is nothing but the 5, right. So, this is something you can easily calculate. The the median number of floors in this particular case is 5. So, we can take a call on that. So, now coming to the next one, that is the mode. So, this is something where the mode is the value that appears most frequently in a data set. It is nothing the average or nothing the middle number, but most frequently appears. A data set may have one mode, only one particular value having the highest number of occurrence or frequency, or that is also called as unimodal, or you can also have more than one mode like bimodal, where you have two mode in the data set, or it can be multimodal, or in some cases there may not be any mode at all if there is no repetition. Say find the mode of this particular data set where 2, 3, 5, 5, 7, 9, 9, 9, 10, 12 they are there. So, in this case you can say that 2, 3, 7, 10 and 12 they only occur once, where 5 occurs twice and 9 occurs 3 times. So, you can simply say that as because it is 3 in numbers the frequency, the 9 is actually the mode of this particular data set. If say for example there is another 5, so then it will be 5 and 9. Example, an architect might be interested in a district most commonly used building materials to understand the local building trends, resource utilization and architectural heritage. The building material used in a sample houses are brick, wood, brick, stone, brick, concrete, wood, brick. So, in this case, as because brick is appears most like 1, 2, 3, 4 times out of all the samples. So, then it is something you can say that brick is that particular thing. So, this is just one example from just kind of context where you can make the count, but definitely the mode is again a mathematical operation. So, where you can get any values as well, right. So, that you can take into account. Coming to the measure of central tendency, in this case also you can see that whenever you have such kind of mean, median, mode, so they are very much symmetrical. So, both the side of mean you have similar distribution, where you have some sort of skew on the left hand side. So, it is negatively skewed, where you have skew on the other side you have the positive skew. So, then obviously the mean will be something greater than median and greater than mode. So, this is the common assumptions. Now, coming to the variability in the data, in this case what we need to do is basically look at the range, look at the variance, look at the standard deviation, right. So, in this particular case, as we discussed earlier, that the moment you have some sort of data dispersion in this particular variability. So, then you have certain sort of issue, like definitely in this case there are certain more deviation that you can say where data is dispersed, and probably if it is too much skewed, so the deviation is not that much. So, let us understand that here the range is the difference between the highest and lowest value in a data set. So, here if the height is concerned, so the highest value is 20 centimeter and then the lowest height is 150 centimeter. So, it provides a measure of spread and dispersion of the values, and then you can see the dispersion along the mean. So, the range is very easy to calculate, where it is the maximum value minus minimum value. So, example, a quick example, an architect wants to understand the diversity in the apartment size within a residential complex to cater to different market segment to ensure variety of living option. So, size of apartments in square meter are 45, 60, 70, 90, 55, 65, 80. So, in this case you can simply identify that 90 square meter is the highest, and then you can see the 45 meter is the lowest. So, here the range is 45 meters, you can 45, sorry, it is not meter, it is 45 square meter, right, in terms of the area. The range of apartment size in this particular case is 45 square meter, indicating a considerable variety in sizes from smallest to largest. When you have those kind of variation less, so almost things are all equal. Now, coming to the variance, variance measures how far a set of numbers is spread out from their average value. It is the average of the square difference. So, in this particular case, if you see that the equation, this is the value, the individual value, and this is actually the mean value. So, whenever we do this calculation for the population, entire population, we represent this with the mu, but when it is sample, normally we represent with the x bar, right. So, this how to calculate, that already we have seen that, okay, for a simple one. So, you can just simply add all those value and divide it by n, okay. So, here I to n. So, and this is the total number of observation. So, similarly for the sample, there is some sort of change in the denominator, where you have n minus 1. So, here n is population in that particular target population, and here it is the sample. So, normally what happen when it is a entire population, so n minus 1 is almost a huge number, so it is equivalent to n. That is the only difference between the denominator used for this sample variance calculation and mean variance calculation. And standard deviation in this particular case is nothing but the square root of this particular variance, where it is the measure which make the amount of variation of a random variable expected about its mean, that how it is varying. Say for example, if you have a certain number, say abruptly I am just giving some number 40, 50, 60, 30, and then maybe if you have the mean value is something like, if you just add all of them, so it will be how much. So, I just make a calculation here. So, it is 180, right. So, in this particular case, if the mean value will be 180 divided by 4, so 45. So, in this case you can see that there is some sort of deviation. So, if you compare it with this, so if you consider this formula x minus x bar, so here you are getting this value is having little bit like this, and here you have 5, here you have you can say that this is 15, and there you have minus 15. So, these are the dispersion from the mean value, the individual case. Now, coming to the variance and standard deviation example. So, this is some sort of rent price for a commercial establishment, and in thousands. So, 200, 220, 240, 260, 280. So, first we have to calculate the mean. If you just sum and then divide it, you get 240. Then you go for variance, the same equation, okay. For your reference I am writing it once again. So, the formula was x minus mu square, that is the square difference, and divided by n. Here n is nothing but 5. So, altogether it is going to give you 800, as variance, and then square root of that is 28.28, which is standard deviation. And in this case, this standard deviation is written as plus minus. So, as because some of the values may be higher than the mean and some values can be like lower than that. So, this is something you can say that standard deviation that may occur. Now, coming to the skewness and you can say the kurtosis. So, in this case already we have discussed it. Let us draw it once again. So, say for example, like if you have perfect distribution. So, they both the site of this particular central value. So, it is having almost equal distribution of data, but you may have a particular skewed distribution where it is something you can say negative, and where you may have the other side which is positive. So, this skewness to the right side positive, skewness to the left side negative, this is something can take place. So, A, B, C. So, in this case this is the skewness. Now, compared to that, the kurtosis is something where it talks about the measure of data peak. So, the distribution can be something like this, or maybe the distribution is something like this, or maybe distribution is something like this. So, in all these cases it is A, B, C. So, in this case you can say that the peak of that kind of mid value. So, there is nothing to skewness, but you based on the data you can have certain value. So, whenever the values are having very low standard deviation, okay, so then you can see the values are around. So, you will get something like this. So, if you get everything like all values are same, like if in a particular exam somebody like all 30 students they scored the same marks, it is nothing but just the line. So, you do not have any kind of distribution, but normally it is not ideal. So, we will have, but if it is around like that is uniformly distributed, but the mean is quite high, the standard deviation is very low. So, you can get something like this as well, but if you see the mean is something low and then it is having some sort of spread. So, you have as low value as say 20 and high value as 90, but in this case it is not the option, right. Now, the last part of this is the measures of this particular position, where you can identify where your data set it is. So, in this case you can say that this is the median value, then you have 25th percentile which is referred as the first quartile, median is at 50th, the second quartile, which normally calculated the interquartile range as Q3 and Q1. So, all the shaded area, and this is the 70th percentile. And then beyond that, definitely if the data lies beyond that particular range and which is not in your data consideration, so then those will be like acting as a outliers and you have to remove it. So, normally in this particular case these are very useful in identifying the outliers and understanding the spread, and then you can comparing different data set how it is being populated. So, for maybe one particular group it is like this, but for others you may have the change in the quartile. It may happen that the median is not that much having high kurtosis, right. So, this is something here we have discussed about this. It can go higher or it can go lower as well. Now, let us summarize this understanding. I am hopeful that the concept and the different components that we discussed in this lecture, they are very clear, because I have given with examples. You can also look at different other examples as well, and if there is any confusion, let me know by writing in the forum. So, in this case we have understood the importance of descriptive statistics for any researcher to get the initial insight of the collected information. Then there are some sort of aspect into it, the measure of frequency, measure of central tendency, variability in data in terms of kurtosis, skewness, the dispersion, etc., and the measure of position where different kind of percentile and quartile where data lies, which will give you some kind of understanding to decide upon the outliers, and then you can take those information, removing outliers for your further analysis. So, with that I conclude here. These are some study materials that even I shared earlier. So, with that we will be moving forward to our next two lectures on representation of data and inferences. Like, you might have very huge amount of information, you might have done certain good analysis, descriptive analysis, but it is equally important to represent those analyses in appropriate manner and how to infer it. So, in next two lectures 34 and 35 we will be discussing on that with different pictorial representation, and then use of tables, figures, etc., how to represent those kind of findings in a research paper or a research writing. So, with that, thank you again for joining, and we will be meeting in our next lecture. Thank you. Bye bye.